This is Samasya magazine of January 2003. This was a very famous magazine or periodical, you can say. It was famous among those students who were preparing for Olympiads in 90s. It may be famous now also. If you can't solve a problem, you can always look up to the answer. But please try first to solve it by yourself. Then you will learn more and you will learn faster. Donald Knuth. Donald Knuth is very famous computer scientist. This magazine was edited by Saleh Sirali, who was principal in Rishi Valley School, set up by J. Krishnamurti. B.J. Venkatachala, who is mathematician of Indian Institute of Science, and C.S. Yogananda, who is also a very famous mathematician in Indian Institute of Science, Bangalore. In this magazine, my article was published. In fact, I can say it is original work in geometry. In my school days, I was very much interested in geometry, and in fact, I became mad after geometry. And few particular problems which I later knew are called as Adventitious angles, and I, I can claim that I have done some original work in geometry. And these types of problems, in fact, started after Langley problem, which was proposed by E.M. Langley in early 20th century, which first appeared in perhaps Acta Mathematica magazine. I'm not sure. Adventitious angles in angle chasing by Sujeet Kumar. Introduction. The fascinating the fascinating universe of Euclidean geometry ever props up new results which are in some sense adventitious. We never expect them, and when we encounter such beautiful configurations, we reel under real joy and pleasure. We start exploring the new relations between lines and angles and wonder the way they unfold themselves. In this article, we see how new relations involving angles which are multiples of 10 degrees reveal the connections between different triangles, and together all of them fit in a global picture. I had written this article when I was in Chennai Mathematical Institute from 2001 to 2003. Though I could not complete Chennai Mathematical Institute clearly, the course of Chennai Mathematical Institute clearly, and I think this article was the only achievement. In fact, this article is the only achievement of my very long and tedious mathematical journey. In fact, there are more, but this started from this magazine only, or you can say these type of problems only. These are very beautiful problems, but one can't understand beauty of these problems until and unless they try to solve it by themselves. These problems can't be solved by usual mathematical techniques. In fact, we can say that there is no sure and short technique to solve these problems. What I have tried to generalize in these articles, I tried to generalize problems involving adventitious angles. In these angles, in these problems, angles are usually not good angles like 30 degrees, 60 degree, 45 degree, but very difficult angles like 10 degree, 20 degree, 40 degree. I invented some new problems and tried to give some new solutions to these problems. And in fact, this whole, you can say, madness started when I saw a problem in Samasya which appeared in Samasya magazine, which was proposed by Samasya January. In fact, many students tried to solve these problems in my school, and one of my friend was successful in solving that problem, and I also gave a new solution to that problem, though which never appeared in Samasya magazine, but that paved a way to generalize these problems and opened a entirely new universe. Again, I will say, just seeing one can't enjoy, one can't understand the beauty of these problems or toughness of these problems. Only one try, then only they can understand. If today, in my days, there was no Google, but today, if anyone search Langley problem on Google, they can get a lot of many new information about these problems. Or later I knew these problems are called as adventitious angles problems. And this problem is also very beautiful. And I was successful in giving a very nice solution to this problem. And most beautiful thing about this problem was that in solving these problems there comes a equation x cube minus 3x plus 1 is equal to 0, and its roots are 2 sine 10 degree, 2 sine 50 degree, and minus 2 sine 70 degree. And corresponding to these angles, three isosceles triangles can be constructed, or you can say not constructed, can be drawn. And they are very interesting and beautiful relations which come up in those triangles. I tried to generalize these triangles, though I was not very successful. I am still working, and I tried to give and I gave those triangles a name alike triangles. I'm still working on those triangles. Let's see what happens. Okay, it was only 16-page article, but it is, I can say that it is new or original. That's it. Though many other problems can be created, which are not multiples of 10 degree but other angles like pi by 7, 12 degree, or many more 6 degree. There is a whole new universe involving these problems. But one must be careful about when they dive in these problems. Because truly speaking, in practical work, there is no use of these problems. But one certainly enjoys it. In fact, if you try to solve these problems, it can even you, that's it. There are other sections of this magazine where people propose new problems, and those who solve those problems, their solution appears in this magazine. And in 1 year only, it is published only 3 times, and it is a very thin magazine. Only one or two articles appear, or three maximum. But this was the perhaps maybe only time where only mine article appeared in this magazine. Mathematics is a beautiful subject. If you can enjoy mathematics, there is nothing more enjoyable than mathematics.